Hello students, welcome to the lecture. In this lecture we are going to discuss the crystal field theory. In previous lecture we discussed the valence bond theory of coordination compounds. This valence bond theory has some limitations and or drawbacks. To overcome these drawbacks are overcome by crystal field theory. According to crystal field theory, the bonding between the central metal atom and ligand arises due to purely electrostatic interactions. So, if ligand is an anion and central metal atom is cation, so there is a attraction between the cation and anion, and due to that attraction, the bonding take place. So, this crystal theory was developed by S.Y.B.Sc. and Blake in 1929. So, this crystal field theory also explains the spectral properties of coordination transition metal complexes. So let's discuss what are the this theory explain the shapes of d-orbital and degeneracy of d-orbital. Let's discuss what are the shapes of d-orbital and degeneracy. So shapes degeneracy of d-orbital. 5 d-orbitals are not identical, but they divided into two groups, that is T2G and EG. These T2G and EG groups are divided on the basis of orientation of this group in space. This T2G have 3 orbitals, that is dxy, dyz and dzx, whereas EG groups has a 2 orbital, that is dx square minus y square and dz square. So let's discuss what are the shapes of that orbital. So in that we can say that the d orbital is divided into two groups, that is T2G and EG. So this T2G groups is divided into 3 orbitals depending upon their orientation in space. So the T2G group is divided into 3 orbitals, that is dxy, dyz, dzx, whereas EG orbital is divided into 2 groups, that is dx square minus y square and dz square. So this orbital is lie in between the dx, so the dxy, dyz and dzx orbital are orientated in between the axes. Whereas dx square minus y square and dz square orbital are oriented along the axis. So in free metal ion, all these 5d orbitals have the same energy. So in free metal ion, all the 5d orbital have same energy, means they are degenerate. So they are degenerate. So this is all about the degeneracy of d orbital. Now what are the shapes of that orbital? Because different orbital have a different shapes, as T2G and EG orbital have a different shape. Let's see. So these are the different shapes of d orbital. Now this d orbital is divided into T2G and EG groups. So what are the energies of this T2G and EG groups? Let's discuss. So if you see the energy here, this is an energy and we have to separate these energy levels. So this is T2G, sorry, this is EG and this is T2G. EG have a higher energy than T2G. So the total energy that is 10 dq, and here for EG it will be plus 6 dq, whereas here that is. So this is a energy distribution, that is 2 orbital here, and for T2G there is a 3 orbital. So for EG there will be 2, and here T2G for 2, that is dxy, dyz, dzx, and here dx square minus y square and dz square. So this is a split. This center, the center that is present in between this, that the total energy of this T2G and EG will be the 10 dq, and there is division of 10 dq, as the EG is a higher energy, so that's why it is in 6 dq, whereas the T2G has a lower energy, so that's why it is a 4 dq. And the average energy level, this is known as an average energy level, so it is a barycenter. Average energy level, or we can say that it is an barycenter. So here this d orbital splitting in octahedral field, so this is, as we see here, and there is a splitting of d orbital into 2 sets, that is EG and T2G. T2G has a less energy, so that's why it is in 4 dq, whereas EG have a more energy, so it is in 6 dq. And the average energy, the total energy of this T2G and EG is 10 dq, and the center which is present, that is an average energy level center, is known as a barycenter. So this effect is known as a crystal field effect. So the effect is known as a crystal field effect. Due to that, the d orbital is getting divided into 2 sets, that is T2G and EG. So now let's discuss what are the assumptions of CFT. Assumptions of crystal field theory. So here there are various assumptions deduced by crystal field theory. The first is that the transition metal which form cation is surrounded by with lone pair of electrons. Means that the simple metal atom is a cation, whereas the ligand is an anion. So there is a force of attraction between the cation and anion. So that's why the bonding will be take place. The second assumption is that the ligand is considered as point negative charges. If the ligand is neutral, then the negative end of the dipole orientated toward the metal cation. The metal cation. Now the next term, that is attraction between metal and ligand is purely electrostatic. The next assumption is that the degeneracy of the orbital is removed when there is approach of ligand toward the metal atom by ligands. When metal is formed. Fine. Whenever the ligand is approaches toward the ligand, so whatever the electron present in metal orbital is repelled by the electron. So the ligand will occupy the metal orbital. So the next assumption is that the electron of the metal ion are repelled by negative field of the ligand. Therefore, metal electron occupy the orbitals which have they are away from the ligand. The number of ligand and their arrangement around the metal will determine crystal field. So the number of ligand and their arrangement around the metal ion will determine the crystal field, and there is a various crystal field will affect the different energies of the orbital. So these are the all assumptions of this crystal field theory. Now we will stop here in next. Thank you.